Alright, so far we have covered the basic arithmetic operations of MATLAB. Now let's move on towards understanding matrices, for which MATLAB actually is an acronym for Matrix Laboratory. But before we move on to matrices, we need to understand about vectors and how two-dimensional vectors actually combine to form matrices themselves. So here we can see that we have declared a variable x equals to square bracket, then we have a number, then we have a space, then we have another number, a space, a number, a space, a number. This itself is a row or a column matrix. If it was in a vertical state, for example, one up, then two down after pressing enter, you had 1, 2, 5, and 1. That would be a column matrix. So this is how we declare a vector. A vector is just a list of numbers in one dimension. This can be said as a one-dimensional declaration of x variable. Okay, because it's just one. It's in a single direction. It's a single line. So this is and because this is a one-dimensional vector, it's also a row matrix. Okay, if it was is vertically arranged, that would also be a one-dimensional vector, but it will be called as a column matrix. So when we combine these vectors in two dimensions, come up with a matrix, a two-dimensional matrix. So if I declare x equals to square bracket 1 space 2 space 3, then I stop with a semicolon, then 5 space 1 space 4 semicolon, 3 space 2 space minus 1, then I'll get an output of this form. This is a matrix that MATLAB will give me as an output. So now let's see how MATLAB actually does that. So the first, I would like to let's just directly create this matrix. It's very easy. So x equals space. Even if I don't give this space, it doesn't matter. It's just for my own ease. I like to keep things clear and neat and clean. So x equals to square brackets. Inside the square brackets, I'm going to write 1 space 2 space 3. 1 space 2 space 3 semicolon. Then I don't need to give this space, it's unnecessary. So 5 space 1 space 4, then again a semicolon. Again, I don't need to give this space, it's unnecessary. Then 3 space 2 space minus 1. So 3 space 2 space minus 1. Now when I hit enter, see what happens. Voila! So it gives you a matrix form. It's so easy to understand and so easy to look at it that you have a matrix, a 3 by 3 matrix here right now, which means that this semicolon is actually an indent. It's actually an indicator that here this first row finishes off, and this is the second row, and this is this third row, right? So if I want a 4 by 4 matrix, what do? I write x. Okay, I'll declare a new variable. So y equals to, if I want a 4 by 4 matrix, so let's see. Let's write 1, 2, 3, 4. Now this space, one more thing to look at is that this space actually defines the column, right? So we have a space after 1, so that means the first column. So there's a space after 5, it means the first column. So the spaces between the numbers define the columns, right? So now here we are trying to make a 4 by 4 matrix. So 1, 2, 3, 4. This is the first row of my matrix. Now I'll write a semicolon. Again, the first column 1 space, second column space, third column space, fourth column space, fourth column. Now again a semicolon. First column, second column, third column, and fourth column. Then I want to write a fourth row. Till now, these are three rows, two and three. Now I want to write the fourth row. So one, two, three, four. Enter. Here we have a 4 by 4 matrix. Okay. Now there are some interesting commands that I can work with these matrices on. So for example, I want to see the size of this matrix. So I write size. Now this is a function. Whenever you write a function, the input arguments are going to be written in within these round brackets. Input arguments means that uh, the variable on which you want to perform that certain operation. For example, I want to see the size of matrix Y. So I write size, round bracket Y, and press enter. It gives me a 4 by 4 matrix. If I press the up button on my keyboard, it gives me the history of commands that are written. And I change this Y value to X, it gives me the size of the matrix X. And as I can see in the workspace as well, these values are declared over here. Okay. So these are vectors and matrices. Then I can also perform some basic matrix operations. For example, I can take a transpose of a matrix. For example, here is the Y matrix. Now the transpose means you convert the rows of the matrix into the column and the columns into columns into rows. That's how you transfer the and switch between the rows and columns of a matrix. So Y equals to Y. Now I want to save this new matrix, the transposed matrix, into the new variable YT. So I write YT equals to Y apostrophe. Press enter, and you see that all the rows 1, 2, 3, 4 have been now converted into columns. So that's how you take a transpose of the matrix.